This is a polarizing filter right here, attached to a binder clip. Notice that there is a small little segment right there and there to give you the orientation of the filter. If I put this up into the light right here, then we can look through it and maintain the focus on the far object. There we go. So that is basically cutting out half the light coming towards me. So we're going to take a second polarizing filter here and put that in between. And we still have, it still basically looks the same. Any light that passes through the first filter is passing through the second filter. So now what I'm going to do is put a third filter in there, or actually, first off, before we do that, I'm going to reorient one of the filters. Both of these filters are oriented the same way, so I'm going to change the orientation of one of the filters, and I'm going to see how coordinated I can do this. So as I rotate this, notice it gets darker and darker, and then I get to the point where they are completely perpendicular to each other, and then I open it back up again, and it is back to where it was. So basically I have radiation coming in one way. This filter allows it to come through, and then if this is oriented the same way, it'll keep coming through, and if this is perpendicular to it, then light that's going this way will get blocked by filter going that way. Light is composed of an electric and magnetic waves. So I have an electric field wave, electric field traveling one way, and then perpendicular to that, I've got a magnetic field wave. So this is an electric field and a magnetic field. If it were coming straight at you, so the light's going this way. So if I were looking at it from this point of view, then what I would see, the way I've drawn it right here, is an electric field acting is upwards, magnetic field is perpendicular to that. So as the electric field goes up and down, the magnetic field moves back and forth. Now, that's the nice simple drawing. In reality, the electric field, you'll have some light with electric field that way, some with that way, that way. You have electric field basically going in every direction, and the magnetic field corresponding to that, perpendicular to it. What a polarizing filter does is it blocks out the electric fields. So if I have an electric field, so if I have a polarizing filter that's oriented vertically, it basically allows any up and down electric field or component to go through. So this one would go through because it's oriented in the same direction as my filter. This one, only part of it would go through. If I take that and I break it up into components, that part would make it through, this part would not. And so any of the vertical components of the electric field make it through. So what's coming out of this is a whole bunch of components, up and down components that are going this way. So if I take a second filter oriented perpendicular to it, then any light that comes through one of them will get blocked by this one, because what comes through the first one has only the vertical components. This only allows horizontal components to make it through. And now for coordination purposes, I'm going to pause this and put in a third filter. All right, so now I have three filters going through here, and they're all oriented the same way. So if I take that middle filter and I rotate it, I block out all the light when it is perpendicular to the other two, and then I keep rolling and it comes back through. All right, so now I'm going to set up so that the first and the third one, the outer ones, are perpendicular to each other. So I'm going to pause this. All right, so what you're seeing is a reflection that all the light has been passed between the two. And as you would expect, the two filters, the farther one away is oriented vertically, and the one closest to us is horizontal. They're 90 degrees to each other. It blocks out all the light. So now I'm going to take the third filter, and I have oriented it at a 45-degree angle to the other two, and I put that in between. And suddenly we can see again. So it's going to require a little paper and pen in order to be able to explain what's really going on here about how come that blocks out all the light, but I stick something in between and suddenly I can see. Do we have magical powers, or is it just physics? Sometimes it's hard to tell the difference. So I have light going in every direction, going through a filter that only allows vertical components. So what's coming through are vertical components of various sizes. If I stick a filter in it that's at a 45-degree angle to that was my attempt at a 45-degree angle, then part of these are going to make it through. So let's do it from this point of view. So I have my electric field, do it this way. My electric field is coming at us. The vertical components make it through. I now have a filter that only allows components at a 45-degree angle to make it through. So I would break this up into its components. That part would make it through. And so what comes through this are things that are going off at a 45-degree angle. Easier from the head-on view. And then if I take another filter over here that's oriented perpendicular to that, in other words, as this is coming through, I have a filter that's only allowing horizontal to go through. Well, part of this will coming through, because if I have a vector going in that direction, I break that into components, that part makes it through. So without that middle filter, everything gets blocked. But with that middle filter, some of it actually will make it through. And that's the explanation for why you get to see it there.